All right, this is the curve of best fit section. It's called VA7 in your book. We're going to be using our graphing calculator. You must have one of these in order to do this section. So grab one and get ready to roll. All right, curve of best fit equation is just the equation used to predict information using data. The coefficient of determination, or the R squared, measures how strong the relationship is between the variables in a curve of best fit. The closer to 1, the number 1 that R squared is, the stronger the relationship. So if it was like 0.97, that's a pretty strong relationship. But if it was a 0.3, that's not very strong. Okay, so when you're doing this, you're going to look for that R squared to be pretty close to 1. And you're going to use this curve of best fit when you have anything with an x squared in the equation. Okay, do not use linear regression because that is for lines. This is going to be for anything with curves. All right, so you're going to have calculator steps. You're going to have stat edit, where you put in your data. Okay, and remember how to clear it out. If you don't, let's see if I've got anything in mind. Hang on, we'll look. All right, so you go to stat, and then you go to edit, which is enter, and you're going to put stuff in L1 and L2. All right, so if you have stuff in L1, you would just simply go up to the top of the column, highlight it, and hit clear enter, and do that for both of them if you had stuff in there. All right, so once you have your data entered, then you're going to hit stat, and then it's going to be calc. Let me just show you. Stat calc right here. And then you're going to pick number 5, which says quad reg, okay, quadratic regression. You're going to write the equation, and then you can find maximum or minimum points from there. All right, so let's go back. So I'm going to have to enter something in just a minute. I'll get that ready. All right, let's go to the next slide. All right, so it says Rodney collected the following data regarding a ball that was thrown in the air. Each data point represents time in seconds and height in feet. Okay, so we're talking about time and height. So time is going to go across here. If you were talking about your X and Y axis. Time in seconds. This is going to be in seconds. And then this is going to be in feet. And that's pretty much what we're going to be working with. What is the equation for the curve of best fit? What is the approximate maximum height of the ball? Okay, so think about it. You know it's going to not just go straight up. It's going to curve and come back down. So that way you know it's going to be a quad reg formula problem. Most of the time it'll tell you curve of best fit. Curve meaning it's quadratic. All right, so you're going to take your information and you're going to put it in your calculator. So you're going to hit all of your x values in L1. So it's going to be 0.5, hit enter, 1, 3, 35, and what's the last one? 4. That's all your x's, and go over to the L2. That'll be your y column, and you type in those. It's 35. 60, 66, 48, 21. All right, so you got all your data in there. And then you want to hit stat, calc, and number 5, which is quad reg, and you're going to hit enter. Now, it's going to give you all this stuff, and A goes right here, B goes right here, and C. You're going to want to round it, though, to probably to at least 2 places after the decimal. So this would be 0.095 would round to 0.10. So you would write the equation is, let's arrange. Did I put all that information in there right? That doesn't look right. Let me go back and check my stat stuff. I've already done this ahead of time and my numbers aren't looking right. 0.5 and 35, 1 and 60, 3 and 66, 3.5 and 48. Oh, that says 35. No wonder. Let's go back. Oh my goodness. All right, let's go down here. Yeah, that doesn't look right. 3.5. That look a little bit better. All right, stat, calc, 5, enter. That looks much, much, much better. Oh my goodness, that was going to be totally messed up. All right, so you're going to write, this is negative 16.7, 70.87, and 4.59. So I'm going to write the equation, and that's going to be y is equal to, and that is negative 16.7 x squared plus 70.87 and plus 4.59. All right, there's your curve of best fit equation. Now it wants to know the maximum, so you would have to go back and look at your calculator, and I'm going to type this in to my y equals so I can look at it. So it's negative 16.7 x squared plus 70.87x. Oops, I forgot my x right there. And that's going to be a plus 4.59. We're going to graph it. Now, that looks horrific. All right, so we want to look at it where we can see it. So I'm going to hit zoom 0. Zoom fit, I believe. Yep. Which is what the picture is right here. All right. If you can't see a nice, pretty curve, zoom 0 is zoom fit, and it should help it. Now, I need to find the maximum. It says, what is the maximum height of the ball? Well, that's going to be that vertex up there. So we've done that before. That second trace, we want the maximum. So you have to move the spider guy. And he is up there at the top, and hit enter. And go over a little bit. And hit enter. And hit enter again. And my maximum is at x equals 2.12. X equals 2.12. 2.12 is seconds, okay? Because our x is our time, our height is my y, okay? All right, so as you can see, go back to the calculator. That height, the highest height now was the approximate maximum height. Whoops, I put down the seconds instead of the height. Oh, okay, seconds. Y is my height, 79.7 feet. Okay, so it will give you, on your calculator, it will give you your y coordinate and your x coordinate. You just got to make sure you know which one's which. Kind of like when we were doing system of equations, you had to define the variables. X stands for time, so in other words, when he hit the ball 2.12 seconds later, it was at its maximum height of 79.7 feet. So the highest point is your y, and then the time it took to get there was 2.12. Okay? All right. Does everybody have that so far? Let me go back and go to the next thing. Oh, that was the only one we did. Oh, okay. We're going to do the rest in class. All right, so the main thing is type in your data, and don't do like I do and forget to check my data because that made it completely off. Go back and check to make sure. This, no wonder, this should be a 3 point. That's what the problem is. I typed it in what was here, and I made a mistake when I typed it in up here. 3.5, okay? Type this in, and then get your equation, and then read the question. It says, what is the approximate maximum height? I like to draw this out Your time is going to be your x, generally speaking, and everything else will be your y. And whenever they do these time problems, that's usually your x. Okay, so because if you think about it, the ball is going to be going up like this. Okay, so this would have to be your height. This is the curve of the ball. Okay, and this is your seconds. Okay, so trying to logic it through. Sometimes it's helpful to just sketch it out so you know what's going on. That way you can know which one's time and which one's height. All right, we will work on these in class. I hope you enjoy this section because you're going to be actually using math to solve real life problems. And I'll see you then.